What are some reasons for temperature variation in Europe, but also in Russia? These are things we should already know. I've already talked about the North Atlantic Current and the role of the Gulf Stream, but some other basic reasons for temperature variation. First off, of course, latitude. As we go farther away from the equator, we're going to get more fluctuations in the amount of solar energy that actually reaches the surface. And so you're going to get much less the farther north you go. And so thus we see, in the case of Iceland and Scandinavia, cooler temperatures than you would in the southern part of Europe, Spain, and Italy and the Mediterranean. So latitude plays a key role. Also, from this map, I can see, because it just solely measures temperature, I can see mountain chains. I can see the Caucasus Mountains. I can see the Alps. So altitude, of course, also plays a key role. Very important in the case of Europe is the role of maritime versus continental effects. Places along a coastline, which are more likely to find in the western part of Europe, you're going to find much more moderating temperatures. The highs won't get as high, but the lows won't get as low. You go into Russia, into the interior of Russia, you're going to get much more extremes in the temperature as you go more continental. There you do not have the moderating influences of a water body, and so thus temperatures get really high in the summer, but then can be unbearably low in the wintertime. So now let's focus in on two different times of the year, the winter versus the summer. And so when we look at latitude, do we see a pattern in terms of greens and yellows at the bottom and blues and whites towards the top? Yes, we do. So here we can further zoom in and look at different times of the year, and we can see the influences of latitude. Can we see the influences of altitude? For sure we can. Once again, you can see the Alps there along the Italian northern border. You can see the Caucasus Mountains. You can see the role of altitude creating situations where as you go up, the temperature goes down. So you should expect to find in upland, highland areas cooler temperatures. Do we see the influences of continental or maritime effects? You can bet your bottom dollar you do. Once again, now let's look at the Mediterranean Sea and the Atlantic Ocean, and you can see essentially around the fringe of Italy, around the fringe of Spain and parts of France and the British Isles, you can see kind of a green ring and maybe even yellow in some parts. Once again, in the winter time, it doesn't get as cool. It doesn't get as cold as it does in the interior, as when we go over to the eastern part of this map, or the right side of this map. When we get over into Russia, you can see in the wintertime, extreme cold temperatures as you get farther away from a water body. So once again, we can see the role of moderating influences of being near a coastline, creating situations where your temperatures don't get as cold in the wintertime versus continental places deep within the continent, which it gets extremely cold. Of course, we can also see in the western part the role of the North Atlantic Current, helping to bring in, once again, some warmer temperatures than we would expect on average without that warm water current. Now, in the summertime, we also can see latitude and altitude at work. We can see, in case of latitude, of course, some oranges and yellows at the bottom, but then you get to the top, more likely to see those greens and blues. Altitude, of course, we can see the Alps. We can see the Carpathians. We can see the Dinaric Alps. We can see the ruggedness of Turkey and the Anatolia Peninsula. We can see the Caucasus Mountains quite clearly. We can even see the rinky-dink, slightly mediocre Ural Mountains in terms of creating a situation where in the summertime they have a little bit of a lower temperature as you go up in altitude, as you go up in elevation. But also, once again, the maritime and continental influences are at work, especially along those coastlines. And so we see the British Isles, we can see Iceland and Scandinavia, in which you have no yellow and mostly a green color, which actually, if you go back to the winter map, they were also kind of in the green colors as well. Once again, emphasizing, I'm being redundant for a reason, trying to emphasize the point in which moderating influence is being near a water body. And as we now put the January and the July temperature maps side by side, we can further see those differences and those patterns I mentioned. But really what this shows is we have seasonality. So we went back to, let's say, Southeast Asia. We can go back to the Pacific Islands. Those particular areas, when we look at their climate regions, we don't see much variation at all. We see, in the case of Europe, very similar to what we saw in Northern America, in which we have much greater fluctuations in the temperature from the winter versus the summer. Now, when I talk about precipitation, we have to, once again, refamiliarize ourselves with the global pressure belts. And so in the case of this particular region, world region, in the case of Europe, we're going to really only see 3 of these global pressure belts at work. The subtropical high pressure, only in the summertime, the mid-latitudes, but also the polar high pressure, only in the wintertime in certain areas. So it's, once again, it's further emphasized, polar high pressure, dry. Mid-latitudes, migrating low pressure centers. We get a little bit more seasonality, changes in weather, warm fronts, cold fronts. Subtropical high pressure, we associate that with, once again, dry areas. So polar high, subtropical high, both, as the name implies, high pressure, we associate with dry weather conditions. So now looking at the January precipitation, we can see, for the most part, continent-wide precipitation. Although when we compare this to the summertime period, much less precipitation. So what's going on here? For the most part, we've got the influences of the polar high pressure, but also the mid-latitudes. And so those places more in the northern part, places like Scandinavia, Russia, they're more influenced in the wintertime by the polar high pressure, which comes down, and with it brings very cold temperatures, but also cold, dry air brings with it very dry weather conditions. So apart from Norway, where it has the right next to it, the water, bringing in moisture, when you get to the interior areas, it's pretty dry during the winter time, as a dry high pressure dominates. Now, the other areas, you do see some more influences of the mid-latitudes. So particularly we see in France and Southern Europe, we see some of the roles of the mid-latitudes. So we see cold fronts, warm fronts, changing weather conditions. And so with that, some precipitation we find in Southern Europe during this time of the year. As we'll get to the other time of the year, we don't see it as much. So once again, trying to emphasize those global pressure belts here in the wintertime, the polar high pressure moves on down and influences Northern Europe and Russia in particular. Now we go to the summertime. Now we're in August, and pretty much everywhere we have more precipitation. And so what's going on there is the polar dry air, the polar high pressure, has moved back up north. And so what's coming to take its spot? The mid-latitudes. And so low pressures that are migrating, bringing with it cold fronts, warm fronts, changing weather, but bringing with it precipitation that occurs throughout the summer months in much of Europe. We can really see that. We can also see a little bit of orographic precipitation. We can see that in the Alps. We can see that in the Carpathians. We can see that in the Caucasus Mountains. And we can also see that to a certain degree with the Ural Mountains. And we can really see that with the Ural Mountains in the January map as well. But we'll go back to that here in a minute. So we do see one particular region of Europe in which we don't see any precipitation. So, and that would be the Mediterranean areas, so Spain, southern France, southern Italy, Greece, Turkey, in which they're actually very, very dry. So what's going on there is they are dominated in the summertime by the subtropical high pressure. Now, in the wintertime, the subtropical high pressure is over the Sahara Desert. But in the summertime, it moves up, and when it moves up, it brings dry conditions. And so in the Mediterranean area, a pronounced pattern exists in which they have a wet season during the winter. Mid-latitudes are influencing, low pressures are influencing. But then in the summertime, they have a pronounced dry period as that subtropical high pressure moves overhead. So very important to keep in mind these subtropical high pressure belts. They move over time, and then the polar high pressure belts, they move over time. That corresponds to different precipitation patterns in different months and different seasons. And here we compare the January and the August. We can see more precipitation in the August time, the summer time period versus the winter, but there are some exceptions. And so we can also see in Southern Europe in January, it's when they get rain. Whereas in August, they get hardly any rain as that subtropical high pressure dominates. Now, I didn't talk much about the Caspian Sea and the Kazakhstan area. Once again, is it Central Asia? Is it Europe? Well, that's to be debated, but we can see here they're pretty much, a subtropical high pressure dominates throughout the entire year. So here with very dry conditions is essentially a B climate, a dry, desert, semi-arid climate that persists through much of the year.